Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the concurrence or the feedback from each one of you regarding the quality of audio as well as video. If it is perfect, just write perfect over the live chat. So at least I'll get to know about the transmission quality regarding the audio as well as video. Anyways, the agenda behind today's video, we'll go ahead with the fifth video on the series of the engineering mathematics, and the past 4 videos were based on the concept of vector calculus, and I was discussing about the basic portions of the coordinate system. So definitely even the agenda behind the fifth lecture is almost lump sum. I would be discussing about the coordinate system, and the coordinate system on which I would be focusing more on today's video is gonna be cylindrical coordinate system. So I would request to each one of you, the student who have gone through the previous video, they should make a proper note, and end of the day they would be able to understand all of the coordinate system, and as the agenda was to complete the vector calculus, obviously the complete vector calculus also. So perfect, no? Okay, then it's fine, So what I would do, let me move into the working board. Let me recall what we have studied in the last class. In last class I have started the cylindrical coordinate system. What I was telling about the cylindrical coordinate system. So far in Cartesian coordinate system, we had the 3 numbers x, y and z, and it was more than adequate to locate a point uniquely over a 3D space. And now instead the x, y, z, I have taken the 3 different numbers which were rho, phi and z. And now this 3 number can also be used for uniquely identification of a number or unique identification of a point over the 3D space. And anyways, these 3 numbers together makes the important 3 numbers over the cylindrical coordinate system. So what I would do at very beginning, I would take a bifurcation, and yes, the focus would be on cylindrical coordinate system. Cylindrical coordinate system. Simply I am writing CS. The few of the important points which we have already discussed in the last class, why don't we start from those points? We can recall those points. What were the first point? The 3 numbers were used. For the unique identification of a point over a 3D space, and they were rho, phi and z. And as I have said in last class, always follow this sequence. Nobody should write phi first, z after, rho after, because anyways, there would not be any misleading when we discuss about the phi, because the phi is the only angle within this 3 number. But if we'll take another alternate, if we'll take another rho, we may get confused between rho and z. So in standard, the pattern of the number which we write for the cylindrical coordinate system, the first number indicates the value of rho, the second number indicates the value of phi, and the third number indicates the value of z. Similarly, if you guys would be able to recall, even we wrote their ranges. So we could know the rho could always be a positive value, that means the rho would be greater than or equals to of 0. If I was talking about the phi, although I did not give the complete understanding of rho, phi and z, which would be the agenda of today's video, but yes, the range of the phi was starting from 0 and was going till 2 pi, including 0 as well as 2 pi. The z is the same z which we have learnt earlier, which could go to minus infinity and can go till plus infinity hypothetically. Yes, this point we have studied in the last class. If you would be able to recall, even I drew a Cartesian coordinate system, and over the Cartesian coordinate system I submerged the rho, phi as well as z. So let me recall how did I do in the last class. So here I had a Cartesian coordinate system, here goes the positive z axis, here comes the positive y axis, and outside comes the positive x axis. Here comes the positive x axis. Yes. Anyways, I would be doing a bit faster because this thing is already been taught in the last class. Here goes the z axis. What did I do in last class? For the unique identification of a point over a 3D space, let's take the point is being placed over a 3D space where in Cartesian coordinate system it was written as x, y, z. What did I do? Simply I dropped this point over the z is equals to 0 plane. I got the value of x, I got the value of y, and the z was the same z which were used in case of Cartesian coordinate system. So the conclusion which we retrieved from this analysis were rho, phi and z can be calculated from the Cartesian coordinate values, and similarly x, y and z can be calculated from the cylindrical coordinate values. Cylindrical coordinate values. So the value of rho which we got to know in last calculation was equals to of x square plus of y square. The value of phi was a tan inverse of the component of y and the component of x, and the z was the same z which we have been learning so far. Even in Cartesian coordinate system and cylindrical coordinate system, as such there is no difference between z. And now if we will talk about x, x was equals to of rho of cos phi, and similarly y was equals to of rho of sin phi, and the z was the same z which we have learning so far. So I could derive till this moment of point in last class. So we will go forward from here onwards. What I would do from here onwards, I would take a new slide, and here let me bifurcate this slide into the two part. See what I am going to discuss over here. If you guys would be able to recall, in Cartesian coordinate system we had few of the important terms like differential length. Once the differential length was done, I moved into the differential displacement. Once it is done, I moved into the differential area. Once the differential area is done, I have taken the unit normal over the differential area, and it became differential area with the unit normal, and at last I was discussing about the differential volume. So that were the parameters over the Cartesian coordinate system. Now those all parameters would be related or would be related over the cylindrical coordinate system. So what I would do, again I would take the reference of Cartesian coordinate system. Just a minute. I would take the reference of Cartesian coordinate system. Here goes the positive x-axis, here comes the positive y-axis, and here comes the positive z-axis. Agreed? Good evening to all of us. Yes. Now what would be happening afterwards, my dear friends? Let's take a situation. I would try to learn the differential length as well as differential area as well as differential volume, taking the reference of this differential volume. Just a minute. I should be drawing it properly. Otherwise, it may not look so appealing. Yes. Yeah. Yes, and here again I would be taking two straight lines. One goes here and the another goes here. Probably you must be able to understand how the curve is exactly looking like. Anyways, let me explain each and individual differential lengths. My dear friends, if you guys would be able to recall, we had the three differential lengths in case of Cartesian coordinate system in the direction of x, y and z. Now here also we would be having the three differential length because of change in rho, because of change in phi, because of change in z. May I know these four pillars what we have now, they are the differential length in the direction of what? Obviously they are in the direction of z. Anyways, if you have the reference of any of these four pillars, definitely you can write they are the differential length in the direction of z, simply can be written as dz. May I know where we are getting d of rho? What does that mean by the d of rho? That means how far you have displaced from the z-axis. You can see very well. Let's take here the rho is rho. Let's take the distance is nothing but rho, and now the differentially I have displaced this point a bit far away. So obviously this is nothing but the length which have come into the picture because of the displacement in the direction of rho. So simply this can be called as d rho. This is nothing but d rho, this is nothing but d rho, and this is nothing but d rho. Yes. So we got the two differential length because of the change in z as well as because of the change in rho. Now the next thing is happening which we were discussing in the last class, my dear friends. Because of change in phi, there is a differential length which we have been experiencing, that is nothing but this differential length, this differential length, this differential length, and this differential length. So many of the times the student do have one doubt, sir, why don't we call it d of phi? My dear friend, if you write d of phi, what does that mean of it? It's the differential angle, and we are discussing about the differential length, so obviously it can't be d of phi. That's the first thing. Secondly, you can see very well, because of the differential angle phi, there was a differential length over here as well as here. You can see very well the differential length over here is greater in compare with the differential length over here in terms of this one, Agreed? I would repeat once again. Because of change in phi, there were the differential length. Here there were a first differential length, here there were the second differential length. May I know exactly where the differential length is more? Here the differential length is more and here the differential length is lesser, although both of the differential length have come into the picture because of the change in phi. What does that mean of it? That means the differential length is directly proportional to phi. Because if you will calculate the length of this circular path from the origin or from the z-axis, it's a smaller, whereas if you will calculate this circular path from the z-axis, the length is more. What does that mean of it? What does it mean? That means this differential length would be affected because of d phi, and at the same time it would also be affected how far it has been made from the z-axis, and which is nothing but rho. So how many differential length you have got it? 3 differential length you have got it, dz, d rho, and at the same time another differential length have come into the picture in the form of rho d phi, because the differential length is directly proportional to d phi and at the same time it is directly proportional to rho. So if you want, we can write one important point. So whenever we talk about the differential length, whenever we talk about the differential length on cylindrical coordinate system, we had one differential length because of the change in z, which we can simply write d of z. The another differential length because of change in rho, which is simply we can write this as d of rho. The another differential length because of change in its phi, and put together it becomes rho of d phi. Why it happens? You can see very well, because this differential length is directly proportional to d phi and similarly directly proportional to rho. You can see very well here the differential length, if I write this as dl1 and if I write the differential length over here, let's take it's a dl2, the dl1 is greater than dl2, although both have come into the picture because of same differential angle, which is nothing but d phi. Yes, no? Yes. So the differential length in future, if I would be talking in terms of cylindrical coordinate system, so you would be having d rho, then you would be having rho d phi, and at last you would be having dz, where the d rho is the differential length in the direction of rho d phi is the differential length in the direction of phi, and similarly dz is the differential length in the direction of z. Many of the times the student do have mistake or do commit mistake, simply they write d phi. My dear friends, it's a simple logic. It can't be d phi. If you write d phi, what does it mean of it? You are dealing with the differential angle and you wanted to deal with the differential length, the rho has to get multiplied. Either you can mug up this, either you can theoretically can relate what I exactly wanted to say. Yes, my dear friends. Now, as most of the time I used to deal with the differential displacement. What does that mean of it? That means I would account the differential length in all of the direction, obviously with its unit vector. So rather writing it dl, I would be writing it dl vector. Whenever you have a differential length and it's a form of vector, by default we are dealing with the differential displacement, rather dealing with the differential length. So here the d rho is the differential length in the direction of a rho cap. Similarly rho d phi, it's the differential length in the direction of a phi cap, and here goes dz in the direction of az cap. Yes, so the differential displacement is also done. Now let me focus over the differential area. Differential area. Like if you guys would be able to recall, when we were discussing about the Cartesian coordinate system, we had the differential areas because of the pair of the changes in xy, yz or xz. The same thing or the same concept would be dealt over here. I can make a differential area because of the cooperation of d rho as well as rho d phi, maybe d rho dz, or maybe the combination of this two. Agreed? But anyways, the analysis is more important. So what I am going to do, I am going to take the three different areas. Let's take the first area is being this. The first area is being this, for which I have used pink color. Yes. Let's take the second area as being this, which I have used the white color. Yes. And the third area is being this, for which I have used the green color. Yes, the three areas we had. Probably you must be able to visualize what exactly I wanted to draw over here. Let me give the name to each and individual differential areas. Let's take this differential areas has been named as dF1. Similarly, this differential area has been named as dA2, and similarly this differential area has been named as dA3. Anyways, let me give a brief idea. The dA1, dA2 and dA3, how they have come into the picture. You yourself would be able to understand this area. Now this curvy area have come because of change in z, and at the same time change in phi, and the change in phi is being addressed as rho d phi. So if you talk about the dA1, you yourself would be able to understand it's simply gonna be dz and rho d phi. So it's nothing but rho d phi into of dz. Yes. Similarly, if you talk about the dA2, you can see very well dA2 is sort of curvy plate which is being placed over the z is equals to of constant plane. Now you can see yourself this area have come into the picture because of this differential length, which is nothing but the rho d phi, and similarly this differential length which is simply equals to of d rho. So here goes d rho and d phi, and along with the d phi always the rho do come. Yes. And once we discuss about this, what are the differential length has been accomplished for designing this differential length, you can see very well there was a change in rho, which is nothing but the d rho. There was a change in z, that's nothing but the d rho dz. Agreed? In last class, if you guys would be able to recall, along with the differential surface area, I was also interested finding the differential surface area along with its unit normal, because sometimes the direction of the surface also make much of sense. So what I would do over here, I would just bifurcate into the two parts. Now instead the differential area, I would be interested on differential area. Obviously the magnitude would remain as it is, but I would also draw the normal on it. Differential area with unit normal. Yes, with unit normal. So what is happening over here? That means rather writing it dA1 alone, I may write it dA1 and the unit normal over the dA1, that's nothing but the an cap separately, or simply I can write dA1 vector. Its choice is used. If the vector has been marked over the dA1, by default it is a vector quantity, vector differential surface quantity, put together it is a differential area with a unit normal. If you talk about the dA1, may I know what was the normal over this surface? Obviously the direction of the normal is in the direction of arrow cap. Many of us may not be able to visualize this, how the normal have gone in the direction of arrow cap, but no worries, because after 5 to 10 minutes I am going to discuss about the unit normals, because I have seen many of these students do have the doubt over the unit normals over the cylindrical coordinate system and at worst spherical coordinate system. So at least for the time being you need not to worry much about it. You can just assume in this way, there was a change in phi, there was a change in z, and hence the unit normal would be in the direction of arrow cap, which I have been doing in case of Cartesian coordinate system. When we had dx dz, by default the unit normal was in direction of ay cap. Same thing is happening over here, because there were no change in rho. Yes, no, there was a differential change in phi, there was a differential change in z, and put together in this complete differential surface there was no change in rho. You can see very well the rho was kept fixed. So in future if you will draw the normal over here, no, the component which was fixed, that would become the normal now. So here it becomes rho d phi dz, and here goes aero cap. Here goes aero cap. Yes. Similarly, if we discuss about dA2 vector, or you can simply write dA2 an cap, what is happening over here? The same concept which we have used earlier is going to be rho d phi. But if you'll talk about this differential area, and if you're interested drawing its unit normal, obviously as it is being placed over the z is equals to constant plane, the normal would it be in positive z direction or maybe in the negative z direction. So most of the time I used to take the normal outside from the closed surface, that is why it has been taken upside. So here I can say it simply equals to of rho d phi, and you can see very well there were the differential changes over the rho as well as phi, but there was no change in z, and hence the unit vector would fall in the direction of Az cap. Yes. Now let me move forward and move it to the third differential area with its unit normal. That's nothing but the dA3. And probably this is the point where most of the students get stuck a lot, because they do not exactly feel the direction of A phi cap. Anyways, I would take the separate few 4 to 5 number of examples just to understand or just to emphasize the concept of A phi cap. So anyways, for the time being, keep aside, just go with the flow. What it is, dA3, there was the change in rho, so here it's going to be d rho. There was the change in z, that is nothing but the dz, and hence the normal is simply going to be in the direction of A phi cap. Hello sir. Anyways, दासुतोष सतपति says, hello sir, आपसे EMFT पढ़ना था लाइव क्लास में, सर कब स्टार्ट होगी EMFT? Anyways, we'll let you know exactly when the live class over the EMFT is going to start. I will let you know. So do one thing, for the better communication, you can post a message over my Telegram chat. So definitely I would reply there itself. No issue. So probably till this point, each and every concept must be clear to all of us. So two of the important things which we could notice, the first doubt the student used to have, from where this rho d phi have come. Yes, whenever you used to have differential length because of change in phi, by default you used to have rho d phi, and the analysis as well as the reason which was properly communicated. So yes, you should have this thing in your mind, because I have seen many of the students, when they used to treat with the differential length in the direction of phi, they just write d phi, which is not the appropriate one. Similarly, the second doubt takes place, how the A rho, Az, A phi comes in the picture. If you are not able to recall the actual differential surface, no, better to use the methodology. There were the differential length in the direction of phi and z. By default, the unit normal which would come into the picture is going to be aero cap. Similarly, if we'll talk about the dA2 vector, there were the differential length because of rho as well as phi. By default, the unit normal would come in the direction of Az cap. And similarly, the same concept goes over. Sir, please repeat once the differential area. So probably Sachin Nayak is saying, sir, just repeat the differential area. So probably I could communicate, and now no doubt would be there within all of these students. So what I would be doing, I would be going forward, and even at last I would be discussing about the differential volume. Yes, I would be discussing about the differential volume. My dear friends, this is what, nothing but the differential volume alone, because there was the change in rho, or the differential change in rho. Similarly, there were the differential length because of change in phi, that's nothing but the rho d phi. There were the differential length change because of z, and that's nothing but the dz. And if you sum them together, definitely it is making a sort of differential volume. So may I know what's going to be the worth of this differential volume? My dear friends, their lengths are so infinitely small, you can just take this as a straight line, you can take this as a straight line, and even you can take this as a straight line. So put together, it is making a cuboid. Yes, no, my dear friends, if you have a curvy contour, but still their length is so small, or hypothetically speaking, it's a differentially infinitely small. So obviously you can take that chord as a straight line, and once you take each and individual chords because of the change in rho, phi and z, straight line, it becomes a cuboid. And what about the area of the volume of the cuboid? It's nothing but the length into height into breadth. The same thing goes out, yes. So you can just assume the 3 length change were there over the cuboid, and once we multiply them together, we get the differential volume, which is simply equals to of rho, d rho, d phi as well as dz, Let me put inside a box. Yes. Sir, is there any change in dz? Yes, no, which we have seen, no. Already there was change in z. This was dz, this was dz, this was dz, this was dz. So 4 pillars on which the complete cuboid has been installed on, it's nothing but the differential length in the direction of z, which we can simply call it dz, yes, which we have already seen, Now few of the important questions I am going to ask from each one of you, and once you are done with those questions, end of the day, you would be visualizing the cylindrical coordinate system in the 3D space, because most of the time I have seen, once we are dealing with the Cartesian coordinate system, the student find themselves very comfortable. But once we go into the cylindrical coordinate system and once we reach into the spherical coordinate system, I know many of the students, they even do not understand what the sir is exactly talking about. Yes, so what I would be doing, I would be taking few of the practice questions. So each one of us should mark it properly. Practice question. The first question like this. What does it mean by rho is equals to 2? What does it mean by rho is equals to of 2? May I know what does it mean by the rho is equals to 2? Whether it's a straight line, whether it's a dense cylinder, whether it's a hollow cylinder. If it is hollow cylinder, what about its height? It has been kept along which axis? So many different aspects we can discuss once we take rho is equals to 2. So just wanted to ask from each one of you, what does it mean by the rho is equals to 2? Tell me, whether it's a cylinder, if it is cylinder, is a type of dense cylinder, hollow cylinder, what about its axis on which it has been mounted on? Tell me. My dear friend, as I have been communicating earlier, how many numbers you have with the Cartesian coordinate system or cylindrical coordinate system or the spherical coordinate system? 3 numbers. My dear friends, out of 3 numbers, if only one number got fixed, like it could have been x is equals to 2, it could have been y is equals to 3, it could have been rho is equals to 2, it could have been phi is equals to 45 degree, it could have been theta is equals to of 90 degree. Yes, I am taking they all to be separate questions. Whenever only one number get fixed, by default the surface comes into the picture. What I am saying, surface comes into the picture. If anybody says we have a mathematical equation over the 3D space, let's take z is equals to 2. So by default one thing should come in your picture, and that, it should be coming in your mind, and that's nothing but the surface. So it's always making surface. Now for the time being, if the 2 numbers got fixed, like you have taken a Cartesian coordinate system where the value of x is 2 and the value of y is 3. These 2 informations have given along with the problem, and whenever the 2 number gets fixed, by default you make a contour. Yes, that contour could be even a straight line in the nature, but end of the day you make a contour. And whenever like even you can take this also, no, rho is equals to 2 or maybe phi is equals to 45 degree. Here also you would be making a contour. Yes. So put it inside a bracket. Yes, no. End of the day, if you fix all of 3 points, like I can take an example. I have got a Cartesian coordinate system where the x is 2, y is equals to 3 and z is equals to 4. Or I can take another example. Over the cylindrical coordinate system, the value of rho was found to be 3, phi was found to be 45 degree, and let's take the z was minus 2. What does that mean of it? That means none of the number has been left to float themselves. They all have got fixed. What does it mean of it? That means you are located at a fixed unique point over the 3D space, and it indicates a point over a 3D space. It indicates contour, and it indicates point. Agreed? What exactly I wanted to say? So you can by heart this outcomes. Whenever only one number is getting fixed, by default you are getting surface. It could be a flat surface, it could be a curvy surface, but the end of the day the result would always be a surface. Tell me what's gonna be rho is equals to 2. Rho is equals to 2. Tell me, I wanted to get the answer from each one of you. The student who are there live, they can give the answer for this particular question. My dear friends, see what is happening over here. Many of the times I have seen the student used to have one doubt. Nothing has been given regarding the phi and nothing has been given regarding the z. What they do, they used to take those values to be 0. It's not like that. Nothing has been given regarding the phi. That means the phi is free to take its minimal to maximum value. That means the phi would take its minimal value 0 and it would rotate and go till 2 pi. That's the first thing. Nothing has been given regarding the z. What does that mean of it? That means the z can take its all possible values, which starts from minus infinity and hypothetically can go till plus infinity. Agreed? No? Whenever you have this sort of problem, no, I know many of the time the student do one mistake. Deliberately they will be choosing phi is equals to 0 and z is equals to 0, which is a wrong nomenclature. Yes. So what I am saying, if nothing has been given regarding the phi would be taking its full circle. That means, yes, the phi would move from 0 to 2 pi. What about z? The z, again the z would take its all possible values. Hypothetically, it can start from minus infinity and can reach till plus infinity. Yes. So what I had to do? I had to draw the rho is equals to of 2 over a cylindrical coordinate system. Again, I would take the reference of z-axis. Here goes z-axis. Here goes positive y-axis, and here comes the positive x-axis. Here comes the positive x-axis. Here comes the positive y-axis. Here comes the positive z-axis. May I know what was the rho? The rho was the perpendicular distance from the z. Let's take the rho is 2. What does that mean of it? Let's take, this is what my z-axis. That means perpendicularly you have fixed a certain point which had the distance from z is equals to of 2, which is nothing but rho. And now even if you rotate taking the reference of this axis, no, and if you rotate in a circular path, still you have been maintaining the distance from the z-axis, which is nothing but 2, and hence the rho is equals to 2 is gonna be a circle over a fixed value of z. Yes, what I am saying, the rho is going to be a circle for a fixed value of z. Let's take at very beginning, I have taken z is equals to maybe 1. At very beginning, I can take that reference. Z is being taken as 1. So it would be sort of this. Just a minute. It would be sort of this. It's a z is equals to 1. Z is equals to of 1. It's gonna be a circle taking the reference of z-axis. Let me draw that circle. The circle would be sort of this. The circle is gonna be sort of this. Agreed now? Each one of us would agree on that. But here I have fixed my value of z, and let's take the z was fixed over z is equals to 1 plane. But as it has been said, you can use all possible values of z. What does that mean of it? That means this circle can be brought towards downside, the value of z is decreasing till minus infinity, and similarly can be brought upside, and we can go till z is equals to of plus infinity. What does that mean of it? You can just assume in this way, you had a ring and you keep expanding towards the positive value of z, and similarly you keep pulling down towards the negative value of z. Put together it will make a cylinder, and definitely which would be hollow in nature. Agreed now? So what I can do now, I can take the reference of let me change the color. I can take the reference of this circle and I can draw a cylinder now. Yes, everybody would agree on this. Just a minute. So here goes the one side of the cylinder, here goes the another side of cylinder. Yes, another side of cylinder. And now if you want, you can complete from the down edge, although it won't be completed, it can go till minus z, minus infinity, sorry. And similarly, you can have the hedged area towards the upside, Agreed? Agreed, no idea friends what I am saying? So this is nothing but the rho is equals to of 2. So if I wanted to know, or if I wanted to write few of the theoretical aspects about the rho is equals to 2. So rho is equals to 2 is gonna be a hollow cylinder. You can write what I wanted to exactly say over here. The rho is equals to 2 is gonna be a hollow cylinder centered along the z axis, having radius is equals to 2, and has infinity length, or has the infinity height. You can see by yourself. If you will talk about its radius is simply equals to of rho. The rho has been taken as 2. That's the first thing. Similarly, if you will talk about its center axis, the center axis is simply a z axis, and if you will talk about its height, definitely it can go till minus infinity till plus infinity. So it's simply gonna be, it's a hollow infinite cylinder. Hollow infinite cylinder. Hollow infinite cylinder having the radius is equals to of 2, centered at z axis, yes, centered at z axis. Agreed, no? Now let me take the next. If I have taken the different reason, let's take initially the rho was fixed, now the rho has been taken from 0, let's take from 2. What does it mean of it? Including 0 as well as including 2. So far what was happening, the value of rho was kept fixed and it was 2. What does that mean of it? That means the circular rotation which has been taken place for a certain point always had the distance 2 from the z axis, a vertical distance from the 2 which is z axis. But now what is happening over here? The rho has been made in between 0 to 2. That means that point could have been rho is equals to 0, and once you will make a complete rotation, it would make a ring which is having radius is equals to 0. Still it is centered at z axis. Now slowly or continuously, if you will increase the rho from 0 to 0.1, again it would make another circle having the center along the z axis. So what is happening over here? The infinite number of circles having the radius from 0 to 2 has been placed over a constant z plane, and now if you will expand them together, it would make a solid, and which is nothing but a dense cylinder. Sir, I am still confused how you write the value x, y, z, phi and theta. My dear friends, there is no doubt, probably you should not have. What I am saying, all of them are interchangeable. At any moment of time, the Cartesian can be changed to the spherical can be changed to the cylindrical, or vice versa. So that is what I am saying. Whenever I take the reference of any of the coordinate system, even at the background, I can use the rest of the coordinate system. So many of the students might be finding a bit difficult, sir, while taking the cylindrical coordinate system, still at the background you used to have x, y, z. That's fine, no, because they are interchangeable. I used to take the reference of each and individual coordinates. Yes. Anyways, the rho is in between 0 to 2. What does it mean of it? It would be simply equals to, let me take the positive y axis, here goes the positive x axis, and outside it would be, just a minute, it would be positive x axis. So here goes the positive x axis, here goes the positive y axis, and here goes the positive z axis. Nothing has been revealed regarding the value of phi. That means the phi can take its own values starting from 0 till 2 pi, and similarly nothing has been given regarding the z. That means the z can take its own possible values, which will start from minus infinity, can go till plus infinity. Now what I would do at very beginning, for just to understand this problem into the better way, I would fix my location. Let's take, I have fixed myself over z is equals to of a constant plane. Let's take its z is equals to 1. Z is equals to 1. Now if I'll take rho is equals to 0, what does that mean by the rho is equals to 0? Rho is equals to 0 is a circle centered along the z axis having the radius is equals to 0. Yes, yes, over the constant z plane. So simply it's gonna be a point. Simply it's gonna be a point. Simply it's gonna be a point. And as I would continuously increase the value of rho, so now it would become a circle with a larger radius, more larger radius, and put together what is happening? Continuously if you will raise the value of rho, no, continuously if you will be raising the value of rho, it would make a circular plate. It would make a circular plate. Everybody would agree on this. Yes, it would make a circular plate. Circular plate. Yes, sort of this. The circular plate over a constant z plane. For the time being, that constant z plane is being taken as z is equals to 1. But as it is being allowed to take the value of z from its all hypothetical values from minus infinity to plus infinity, that means we have got a circular plate. Now the circular plate has been switched towards upside, and similarly it has been stretched towards downside. Obviously now it would make a dense cylinder. If you want, we can draw over here. It would make a dense cylinder. It would make a dense cylinder like this. It would make a dense cylinder, sort of this. Anyways, I need to take the hedged line towards downside because it can keep go towards the positive value of z as well as negative value of z. Positive value of z as well as negative value of z. Yes. No, we will be talking about each and everything. No issue, no issue. So here it becomes a dense cylinder. Here it becomes a dense cylinder. Here we are discussing about a dense cylinder. Agreed now? Agreed? So if I discuss rho is equals to 2 or rho is equals to constant for the time being, it would be a hollow cylinder centered along the z axis and having radius is equals to of 2. What about the height? Height is infinity. Height is infinity. Now here what I have done, rather fixing the value of rho, the rho has been taken a range in between 0 to 2. So obviously in between 0 to 2 the value of rho is going to be a solid. Here it has been started from 0 and went till 2, so obviously it's going to be a solid cylinder. Even you can have another example. You can have another example. Anyways, I would not draw over the digital board. Even the rho could have been in between 2 to 3. What does that mean of it? That means now you had to take an annular circle where the rho starts from 2 goes till 3. You can place over a certain fixed value of z or the fixed z plane, and now it's going to be a annular circle. And once you extract towards upside and similarly once you stretch towards the downside, now it would become an annular cylinder. What does that mean by the annular cylinder? That means the cylinder which have got a certain thickness, it has got its internal radius as well as the external radius. Still it would be centered along the z axis. Could you understand what I am saying? It was a dense cylinder, but it would be an annular cylinder. 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 Yes? Yes, no? Yes, my dear friends. Now what I would do, I would take few more critical questions, and I know these are the questions where many of the students used to have doubt. Phi is equals to of 0 degree. May I know what do you understand by phi is equals to 0 degree? What do you understand by phi is equals to 0 degree? My dear friends, see this leaf, probably, okay, let's take this is what my z axis. This leaf, whatever the angle is produced by the z axis is going to be the value of phi. It's going to be value of phi. Agreed what I am saying? I would repeat once again. This was phi is equals to 0. Phi is equals to 0. Just a minute. This was phi is equals to 0, and as I have started expanding this page, there was a formation of angle in between. Keep in mind this plane was the plane phi is equals to 0, and as the value of phi is keep increasing, the value of phi is increasing. So exactly may I know what does it mean by phi is equals to 0 degree? What does it mean by phi is equals to 0 degree? I would like to ask from each one of you, what does it mean by the phi is equal to 0 degree? Could you understand how it would look like? The phi is equals to 0 degree would look something like this, and in Cartesian coordinate system, can't we write this as y is equals to 0 plane? Can't we write this as a y is equals to 0 plane? Tell me, can't we write this as a y is equals to 0 plane? Yes, we can. You can see very well in the complete surface, anywhere at any point the value of y was a constant, and what was the worth of y? The worth of y was 0. So may I know the phi is equals to 0 degree, can I write y is equals to of 0 plane or not? Y is equals to of 0 plane or not? Tell me yes or no. I would like to ask from each one of you, from the student who are there live over the live chat. Yes, we can write, but one important thing, if we talk about the y is equals to 0 plane, the y is equals to 0 plane, that means the values of z, r and as well as x, they are free to take its own values. Z can go till plus infinity, till minus infinity, no problem. It can go to the plus infinity towards x direction, even it can go towards the minus infinity towards the back direction, which is not permissible. Sir, can you explain the thickness part of the cylinder? Not required, Vijay, not required. Now tell me, phi is equals to 0, can I say the phi is equals to 0 as y is equals to of 0 plane having x greater than equals to of 0? That means it is a type of semi-infinite plane. Infinite plane. When you are able to connect the Cartesian as well as cylindrical coordinate systems, the things becomes much easy, because your brain works sharply once we try to make your brain understand into the Cartesian coordinate system. That is why deliberately I have brought phi is equals to 0 into the Cartesian coordinate system where the y becomes 0, Now I would like to ask from each one of you, rather taking phi is equals to 0 degree, let's take the phi has been changed to the 90 degree. How will you correlate phi is equals to 90 degree surface over the Cartesian coordinate system? I would like to know from each one of you how the phi is equals to of 90 degree can be taken into the Cartesian coordinate system. My dear friends, initially it was like this when the phi was 0. Now as it is tilting, the phi keep increasing, and as it overlapped over this digital board, the phi became 90 degree. Otherwise, see, this was 0 degree, and as it is keep opening, the phi is increasing, and now it became phi is equals to of 90 degree. What does that mean of it? That means phi is equals to 90 degree is lying over this digital board, and this digital board is nothing but the x is equals to of 0 surface, which we have seen in case of Cartesian coordinate system. X is equals to of 0 surface. Yes. So here I can write x is equals to 0 surface. Phi is equals to 90 degree. That means we are talking about this surface. It can take its own values, can go till plus infinity to minus infinity, and similarly it can take its own value of rho, can go from 0 to plus infinity. Agree? Till this point each and everything must be clear. But as I am writing x is equals to 0, that means the value of y can be taken positive as well as negative. But at least over phi is equals to 90 degree, the slab which we had to cover, the infinite plate which we have to cover, that has to be covered just at the right hand side of the z axis. That means the value of y precisely has to be positive alone. That means phi is equals to 90 degree can also be written as x is equals to 0, possible only for y greater than equals to of 0. Yes, my dear friends, would you be able to understand what exactly I wanted to say? Now what is happening over here? Let's take the fifth question. And the fifth question is phi is equals to of 180 degree. Tell me, how we can convert phi is equals to 180 degree into the Cartesian coordinate system? I want to know from each one of you how the phi is equals to 180 degree can be written into the Cartesian coordinate system. My dear friend, this was phi is equals to 0, this was phi is equals to 90 degree, and this was phi is equals to 180 degree. What does that mean of it? That means you have taken the rotation 90 and 180 degree. That means you can see like this. As this is keep opening, the value of phi is increasing. Here we went into the 90 degree, and when I came back, the value of phi became 180 degree. Value of phi became 180 degree. May I know exactly? Phi is equals to 180 degree indicates which particular space of region in Cartesian coordinate system. Here goes the z-axis. It talks about the backside of the z-axis, and we can simply write again. It is a y is equals to of constant plane. Y is equals to of constant plane, but x is lesser than equals to of 0. The reason is x is less than equals to 0. So whenever somebody says phi is equals to 180 degree, it is a type of semi-infinite plane. Semi-infinite plane. Semi-infinite plane. Yes. And similarly, here phi is equals to 90 degree. Again, we call it semi-infinite plane. Infinite plane. Infinite plane. Now one thing comes in mind, sir, why we call it semi-infinite plane? Infinite plane, that means there is no restriction. It can keep go towards left hand side, right hand side, upside and downside. But here you can see very well, it is possible to move towards right hand side, upside, downside, but it has got the limitation towards left hand side. It cannot go beyond y is equals to 0. That is why rather calling it infinite plane, I used to call it semi-infinite plane. Semi-infinite plane. Yes, no? Semi-infinite plane. So now, anyways, I would go bit advanced. Anyways, before going bit advanced, I would like to ask from each one of you, the student who are live on our live chat, how many of the students are from the southern part of the India? That means a student who are not well comfortable with the English at all. And how many of us who have been following us, which are from the Hindi or the northern part of the India. So at least I'll get to know what about our proportionality which we have been following so far. Tell me. You can simply write northern or the southern part. So at least I'll get to know what about our percentage student. And one more important thing, anyways, I have planned to take the two important topics within the engineering mathematics, which was vector calculus. The secondly was the probability distribution and density. If you guys are finding bit difficult any certain particular topic or certain particular subtopic within the engineering mathematics, you can write over the live chat. So at least I would get to know those topics. If the time permits, I would try to accommodate over this series of mathematics. Tell me. What I am saying, anyways, in this series of engineering mathematics, which helps in between 9 to 10, only two topics I have planned to take. The first was the vector calculus. Once we are done with the vector calculus, I have planned to take the probability distribution and density. If still any of the topic which you guys find very difficult, I would try to accommodate that also. Yes, Omkar Raval is saying complex variable. Even I thought to take that topic. If the time permits, definitely I would be discussing about the complex variable also. We'll try to get to know how the closed line integral becomes 0 when we do the closed line integral in a complete analytic function, or the reason of the complete analytic function. And similarly, why the complete line integration becomes a residue of a certain function over a non-analytic point. Yes, we can discuss about those important concepts, because end of the day in engineering mathematics we just by heart the Cauchy's contour integration in complex variable, but we do not go into the detailed analysis. If the time permits, definitely I would be discussing about those also. Yes. Now let me go ahead. If I take the next question, the question is like I have taken rho is equals to of 2 and z is equals to of 0. Anybody? would try what would be the structure of this particular EM. What would be the structure of this particular EM? Tell me. Now here the two datas are got fixed. As I have been telling earlier, whenever the two datas are getting fixed by default, the outcome would always be a contour. Always would be a contour. So forget about a point, forget about a surface, it would be a contour, or it would be a path. So tell me which type of path it's gonna be. Sir, ISRO interview का tough process कैसे develop करें? Okay, ISRO interviews. शिवम उपाध्याय saying ISRO interview का tough process कैसे develop करें? Okay, we'll try to develop the concept over there. We'll try. If the time permits, definitely I may plan one session over the ISRO. Tell me, rho is equals to 2 and z is equals to 0. What about this structure? My dear friends, the z have become 0. What does that mean of it? That means whatever the structure would be made, by default it would be made over z is equals to a 0 plane only. Z is equals to a 0 plane only. That means the structure cannot go beyond z is equals to 0. Yes. So here it goes x, here it goes y, and here it goes z. Anyways, z is equals to 0 plane. It's gonna be a xy plane where the value of z has been fixed to 0. So let me draw that. So here goes z is equals to a 0 plane. Yes. Here goes z is equals to 0 plane. It can keep go towards a positive value of y, negative value of y, positive value of x, negative value of x, but yes, it would be fixed to z is equals to 0. And now rho is equals to 2. What does it mean by the rho is equals to 2, which we have seen earlier? Rho is equals to 2 is nothing but a hollow cylinder having the height is equals to infinity and centered along the z axis. So now thing goes in this way. We have got a cylinder which is infinite in height. This is one side of the cylinder and this is the another side of the cylinder. Yes. Let me complete this. Anyways, I do not have to stick myself over rho is equals to 2 alone or z is equals to 0 alone. We had to take a reason where both of them are getting satisfied. That means the reason where the z is 0 and even the reason where the rho is equals to 2. That is possible only if this complete cylinder is making a projection over the z is equals to 0 plane, which is going to be a circle having the radius is equals to of 2 and centered along the origin and placed over the z is equals to 0 plane. Yes, no? If you will take this structure, the structure would be sort of this. Yes. This is the reason which I was looking for. So if I say rho is equals to 2, z is equals to 0, it's going to be a circle centered at, my dear friends, whenever we discuss about this circle, I do not say the centered at z axis because precisely I can know it has been centered at origin for the better clarity, origin, and yes, placed at z is equals to 0 plane. Yes? Agreed, no? So till this point probably nobody should have any doubt. So we were developing the concepts over the cylindrical coordinate system. Anyways, once we will come back with the same series of the mathematics tomorrow, what I would do, I would take few more number of examples from the cylindrical coordinate system, and once we are done with the cylindrical coordinate system, we will move forward over the spherical coordinate system, and once we are done with the spherical coordinate system, we will simply jump it to the vector addition, vector multiplication, vector differentiation, vector integration, and which are the very important points over the vector calculus. Yes. So I would like to ask from each one of you, any sort of doubt you guys have got in today's lecture, you can ask over the live chat. I will go through your live chat, and end of the day, we would be finishing or we would be binding up my video here itself. What is the mean of contour? My dear friends, see what happens. The contour is simply path. See, if it is a straight path, I may call it a straight line, straight line. But if I am following a certain path where the structure does not falls under the straight line, still we can call it a path, a type of path, but I am not specifying whether it's a straight line or not. So end of the day, whenever I say the contour is gonna be a contour is gonna be a path. And if the contour is a straight contour, simply it can be called as a straight line or a straight path. So this is also a contour. Yes, this is also a contour. Even this is also a contour. The contour is simple a path. And in few of the books, the contour has been defined as a path whose mathematical definition is well defined. Yes, no? So what I would do, at least I would give a rest to today's video, and we'll meet precisely at 9 PM tomorrow. Till then, bye bye, take care, good night.